Okay, so today I'm here with lecture 4 of chapter 3, right? Yesterday I dragged resistance, right? So yesterday I dragged resistance is equal to rho L by A, right? So this is your resistance, right? But today we are going to discuss some definition related to resistance, right? So just like what is resistance, these things we are going to discuss, right? So first one, resistance, right? What is resistance? Okay, resistance, resistance is represented by R, right? And what is resistance? It is inherent property of material, right? Inherent property of material due to which it opposes flow of current, right? So we can write it is inherent. It is inherent property of material. Property of material, okay? Due to which it opposes flow of electric current, okay? Flow of electric current, okay? Flow of electric current, right? And now, what is the unit of resistance, right? So unit of resistance is ohm, right? These things are non-real, right? So if I am going to talk about unit, right? Unit will be ohm, and symbol of ohm is this one, right? And now next we are going to discuss factor affecting the resistance, okay? What are the factors which affecting the resistance, okay? So factor affecting the resistance, okay? As you see, resistance is equal to, what is the formula of resistance? Rho is equal to L by A, right? You know this formula, right? So from this formula you can see here where L is length, right? L is length. Better we can write like this, okay? This is also length, right? So here you can see if length of conductor will increase, resistance will increase, right? And area, see, if resistance decrease, if area will increase, right? So these are the factor. And one more thing, resistivity is for different material, resistivity is different, right? So on the material, resistance is also depend on material, right? So first factor affecting the resistance, right? So first factor is length, right? Okay, so length. So from here you can see R is directly proportional to L, right? L is directly proportional to L. So we can say that if length of conductor increases, then resistance will also increase. So resistance will also increase, okay? And second point is cross section area, right? Or we can say like area of cross section. That means we are talking about A, right? We are talking about A, okay? So from here you can see R is inversely proportional to A, right? So if area will, so from here we can say if area of cross section increases, then resistance will decrease. will decrease, yes or no? Right, resistance will decrease, okay? And third point, see, this rho is having different value for different material, right? So resistance is also depend on material, right? Material, okay? Why depends on material? Because different material have different value of resistivity, right? So if value of resistivity is different, then resistance will be different, right? So we can write here different material have different value of resistivity. That's why resistance will be different, right? Different will be different for different material, right? Resistance will be different for different material, okay? And last one is temperature, right? In last class I had dragged one formula, right? What was the formula? Resistance at temperature 2 is equal to resistance at temperature 1 into 1 plus alpha T2 minus T1, right? So you know this formula, right? So see, as temperature is changing, right? So resistance will change, right? So for different value of temperature, resistance will be different, right? Okay. So we can write for conductor, for metal, resistance increases with increase in temperature, right? Okay. So see, this is all. If metal, for metal temperature will increase, resistance will increase, right? But for semiconductor, resistance will decrease with increase in temperature. Why? Because semiconductor is having negative value of alpha, right? So we can say for semiconductor resistance will decrease with increase in temperature, right? You can see this thing for metal increasing with increase in temperature, right? But for semiconductor it is decreasing with increase in temperature. Why? Because for semiconductor alpha is negative, right? Alpha is having negative value, right? And for metal alpha is having positive value, right? So here alpha is positive, right? And here alpha is negative, right? So alpha is positive, so value will increase if temperature will increase, right? But if alpha is negative, this term will increase, so value will decrease, right? So next I am going to discuss about resistivity, right? Okay. Before that I discuss conductance, right? You have written resistance, right? Next one is conductance, okay? So note it down. Okay, this is if, okay, semiconductor is. Okay, so note it down fast. Then I will discuss conductance, okay? Finish, okay? So next one is conductance. Okay, so conductance. Conductance is basically represented by C, right? And C is equal to 1 by R, right? C is equal to 1 by R, okay? Next, what about the unit of conductance? So unit of conductance, right? So C is your conductance, right? And C is what? 1 by R, right? And resistance is having what unit? Ohm, right? So unit of conductance will be ohm to the power minus 1, right? Or this one is also written like this, or moho. Moho is the unit of conductance, right? And symbol will be like this. Okay, so this is your symbol for conductance. Yes. Okay. Next, we are going to discuss resistivity, right? So, what is resistivity? Resistivity, right? So, resistivity. Resistance, resistance offered by, resistance offered by, resistance offered by unit length and the unit cross section area of a material is known as resistivity. Right? Okay. Next, we are going to discuss factor affecting the resistivity. Okay. Factor affecting the resistivity. Okay. So factor affecting the resistivity, right? So first one is material. Okay. Material, okay. For different material, resistivity will be different, right? Okay. For different material, resistivity will be different, okay. Next. Okay. So next one is temperature. Right. In last class, I derived one formula. So what was the formula? Rho at temperature T2 and rho at temperature T1 is 1 plus alpha T2 minus T1, right? So from here, you are able to see that resistivity is varying with temperature, okay? So we can write resistivity of material is changing with changing temperature, with changing temperature, okay. So one more thing we have to discuss, unit, right? Unit of resistivity, right? Right? So you know this formula, resistance is equal to rho L by A. So from here we can write rho is equal to RA divided by L, right? And resistance of R is ohm, and for area meter square and divided by length meter, this, right? So unit will be ohm meter, okay. Ohm meter is the unit of resistivity, right? Okay, so no doubt. Okay, so we have written this part, okay. So one more thing we have to discuss, conductivity, right? So conductivity is 1 by resistivity, right? Just like that, resistance and conductance, right? Conductance is equal to 1 by resistance, right? So that things we are going to discuss. Okay, so now I am going to rub this part. Conductivity, right? And conductivity is represented by sigma. And conductivity is defined as, conductivity is basically sigma, and this sigma is equal to 1 by rho. Next one is unit. What about the unit? Unit of conductivity. So your conductivity is 1 by resistivity, right? And resistivity is having unit 1 by ohm meter. Okay. So further we can write like this: ohm meter, or we can write like this: 1 by ohm. 1 by ohm is what? Moho, right? So moho, and meter will go up, right? So it will come meter to the power moho per meter. Okay. So this is your unit of conductivity, right? Or we can write like this also, right? Or moho meter, right? So whatever is there for you, write like that. Okay. So these are some basic things regarding your resistivity, conductivity, resistance, and conductance, right? So I have discussed all these things, the unit as well as what is resistance, what is resistance, right? So you try to remember it, okay? Okay, so next I'm going to discuss ohmic. Okay, so next I'm going to discuss ohmic conductor and non-ohmic conductor, right? So you have written this part now, so I'm going to learn it. Ohmic conductor. Okay, ohmic conductor. So what is ohmic conductor? The conductor which follows Ohm's law is known as ohmic conductor, right? So we can write the conductor which follows Ohm's law, right? Which follows Ohm's law. And what is Ohm's law? R is what is Ohm's law? R is constant, right? Constant with V and I, right? The conductor which follows Ohm's law is known as ohmic conductor. Is known as ohmic conductor. Okay.
Sir, which flows or which follows?
Okay. Which follows now? Yes. Which follows Ohm's law. The conductor which follows Ohm's law is known as ohmic conductor, right? Similarly, we can write non-ohmic conductor, right? Non-ohmic conductor. So the conductor which does not follow the Ohm's law is known as non-ohmic conductor, right? So we can write like this: the conductor which does not follows Ohm's law. Does not follow Ohm's law, that means R is variable, right? R is variable, is known as non-ohmic conductor. So note it down. What is ohmic conductor? What is non-ohmic conductor? Okay. Now I'm going to take one question. Okay. With the help of that question, we are going to calculate resistance of a conductor, right? So I have to write that question. So I will write that question in this part. Okay. Okay. Question is a little bit big now, so I'm only taking the value, right? The data given in the question, and I will solve the question, right? In this question, we have to find resistance, right? We have to find resistance, okay? And two things are given, and some data is given in the question. Just I'm going to write the question, and after that I will read the question, okay? Because if I write the question, it will take time, okay? Given. First one is length is given, right? First one is length is given. Length is how much? 10 meter, okay? And area is also given in the question. How much is the area? 1 meter square, millimeter square, right? And resistivity is given. Resistivity of copper, okay? is how much? 1.7 into 10 to the power minus 8 ohm meter. Okay, and resistivity of aluminium, AU, right? And that is how much? 2.4 into 10 to the power minus 60 ohm meter, right? So basically, right now we are going to calculate resistance of copper as well as resistance of two conductor, right? One is made of copper and one is made up of aluminium, right? But the length and area of both the conductor is same, right? So I have to solve it. So I will run this one. Suppose first I am going to calculate resistance, right? Resistance of copper, Cu, Rc, right? Resistance of copper, Rc means resistance of copper, right? That will be how much? Rho L by A. You know this formula, resistance of copper is equal to. So here Cu will come, right? And we will substitute the value. Value is given. Rho is how much? 1.7 into 10 to the power minus 8. Length is how much? 10 meter. And this area is given in millimeter, right? So we have to convert it to meter square, right? To convert it to meter square, we have to multiply with 10 to the power minus 6. So now this area is converted into meter, right? So yes, I will substitute that value 10 to the power minus 6, right? So here you can see this is 10 to the power 6, this is 10 to the power 8, right? So it becomes 10 to the power minus 1, right? Sorry, minus 2. 10 to the power minus 2, 10 to the power minus 2 and 10 to the power plus 1, right? So further we can write like this. So if you are going to solve it, this value will come 1.17 ohm, right? So this is your answer, okay? Next, resistance of aluminium, right? Resistance of Al, right? Resistance of Al, aluminium Al. So resistance of aluminium is Al and RAL is rho Al length by area, right? This value is how much given? 2.6 into 10 to the power minus 6, and length is how much? 10, and this is again 10 to the power minus 6. So 10 to the power minus 6, this cancel, right? So 26 ohm will come, okay? Okay, so note it down. So you have written this part is right. So okay, one more question I'm going to take. So I'm going to rub this one. So question, this question is saying that calculate resistance, right? Calculate resistance, okay? And this figure is given in the question. Okay, so I hope you are able to visualize this picture, right? So this picture is given and we have to find resistance, right? Okay, so resistance we have to find. Area is given, area is not given. This length is given L, this length is given L, right? This length is given B, and this length is given H, right? And this one is your A face, this is your B face, this is your this is A corner, B, C and D, right? Okay, and similarly this is your D, E, F, G. Okay, So calculate resistance. Okay, calculate resistance. Two questions is given in this one, right? First one is we have to calculate resistance across this phase as well as this phase, right? Resistance. Calculate resistance of conductor. Calculate resistance of conductor. Conductor A, B, C, D, and E will come, right? E, F, G, H. Okay. So this is your question. Note it down, and we have to solve it. So this phase and this phase, we have to find resistance across this phase and this phase. Okay. So suppose this is your this one, right? So basically, in first question, suppose this is your A, B, C, D, A, right? This is your A, B, C, D, and this is your E, F, G, H, right? So we have to find resistance across these two phases, right? So if I'm going to find resistance across this phase, so current here, if I'm going to find across resistance across these two phases, current is passing like this, right? Then what will be cross section area? This is your cross section area, right? And this one will be your length, right? So first question, if I solve it, so we can write like this. So first question, answer of first one, resistance is equal to, you know the formula, rho L by A. This is your formula, right? And rho and length is how much? See, this will be your length, right? And here how much? L, right? And what about the area? Area is this one, right? Okay, area is this one. And this area is how much? You can see this is area is how much? B into H, right? So B into H. So this is your answer of first question. And second one, if I am going to solve, right? So second one, how we calculating resistance across inside phase as well as this phase, right? So current is flowing like this. Current is coming inside towards me, right? So current is coming towards me. So this will be your area, right? This will be your area, and this one will be your length, right? So further we can write like this. So R is equal to rho, and your length is this one, right? And this length is what? B, and area is this much, right? And this area is how much? L into H, right? So L into H. So from this example, see, this one resistance is something else, this is resistance something else, right? So from this example, we are able to say that for same conductor, right? If direction of flow of current is different, then resistance will be different, right? As you see, when current is flowing like this, going inside and coming out from here, right? So resistance is coming this much, right? But current is coming like this and coming out from this one, so resistance is coming through this one, right? So it is also possible for same resistance, right? For same conductor, if direction of flow of current will change, then the value of resistance will change, right? So that time you have to consider the area which is perpendicular to current, right? So in this one, the current is flowing like this. In this one, current is flowing like this, right? Current is going inside, right? So this is your area perpendicular, right? That's why I took this one, right? And length is along the direction of current, right? So I hope everything is clear to you, right? Still I have 10 minutes time, right? So some more question I have, so I will solve that one. So note it down. Okay, so this is your phase P and this is phase Q, right? We have to find resistance between phase P as well as phase Q, right? But here you can see your resistivity is varying with X. So suppose if I am going to take coordinate axis like this, so this is your X axis, okay? This is your Y axis and this is your Z axis, right? So as you will move in this direction, value of X will change, right? See, huh? If I am taking coordinate axis like this is your Z axis, right? This is your X axis and this is your Y axis, right? Here see, your resistivity is varying with X, yes or no, right? For different point, if you are taking point here, so resistivity will be different because this point is having different value of X. So your as you will move in this direction, value of X will change, right? So value of X is changing, your resistivity will change, right? So we are not able to apply this formula. Directly we are not able to apply this formula because here resistivity is changing with X, okay? So to solve this question, we have to consider a small element, right? Suppose I am considering here very small element. Suppose so what I did, I went to a x distance from this one. I consider a small element dx, right? I consider a small element dx, right? For this small element, we are able to consider that resistance is constant, right? For this small element, we can consider resistance is constant, right? So a small resistance due to a small element is dr, right? And that dr will be rho dx by a. Now rho is having how much value? Kx, right? This is your dx divided by a. A is the area of this one. This is not changing, right? So see, what is Cam? This value is Cam, right? Now this is resistance due to a small, right? So by integrating this value, we are able to get total resistance, right? So just we have to go for resistance, and value of L is varying from 0 to this length is given in the conductor, right? This length is given and this length is L, right? And this area is also given in the question, that is A, right? So value of X is changing from 0 to L, right? Here 0 to L. So K by A is constant, A is constant, right? It will come out. So you have 0 to x dx, right? Integration of K by A, integration of x dx is what? X squared by 2, and this is okay. So if you substitute the value, so you will get the answer K L square. You will get the answer K L square by 2, right? So this is your answer, okay? And we calculating resistance, so unit will be ohm, okay? So this way, if conductivity is varying, then by integrating you will be able to get the answer, okay? Okay, so that's all for today. Note it down.